Welcome to the fifth section in this series about finite projective planes. I'm going to explain to you now why a double deck fulfills all the criterion of being a finite projective plane of order Q. Now, it's important to understand what is a finite projective plane. So, it is that each line has Q plus 1 points, and each point appears on Q plus 1 lines. Any two lines are connected by exactly 1 point. Any 2 points are connected by exactly 1 line. And now I'm gonna let you pause the video and think how you can relate this back to what you've learned so far and explain why the Dobble pack forms a finite projective plane. We're asked to explain why the Dobble game with 3 symbols that we created forms a finite projective plane. Well, each card has 3 points on it, or 3 symbols on it, and each symbol appears on exactly 3 cards. So each card has 3 symbols, and each symbol is on 3 cards. And again, you can loop back to your Levi graph to verify this. Now, additionally, any 2 cards that intersect, or any 2 cards share exactly 1 point, or in this case, 1 symbol. So 2 of our cards are connected by 1 symbol. Think back to our Fano plane. There was only 1 line connecting each pair of symbols. And additionally, any 2 points, so any 2 symbols, are connected by exactly 1 line. Okay, so that means that 2 symbols appear together on 1 card only. So we have actually fulfilled all of the criterion of a finite projective plane. It asks us, what is the value of Q? Well, we know that in our case, if it's Q plus 1 points or Q plus 1 symbols, we had 3 symbols. So in our case, Q would be 2. Okay. What is the relationship between S and Q? Well, we know that the number of symbols must equal to Q plus 1. So in our case, S minus 1 is equal to Q, or S is equal to Q plus 1. So that's how we would link them together. In the next section, in section 6, I'm going to teach you how you can effectively and efficiently construct any pack of cards. What's the easiest way to work out what should be on the first, second, third, in our case, up to the 7th card? What's the quickest and easiest way that we can allocate symbols to cards so that we fulfill all of the criterion, including being a finite projective plane? So that's what's coming up in section 6, which was part of our aim, which was to look at how we can effectively and efficiently construct a pack. So I will see you in the next video. Please don't forget to like and subscribe.